Welcome back to our automotive testing series. In the world of modern automotive engineering, safety is not just a goal, it's a rigorous architecture. Modern vehicles contain millions of lines of code, and without an engineering anchor, testing strategies drift. The root cause of most automotive software catastrophes is not poor coding, but a fundamental disconnect between system intent and validation execution. This is why we rely on requirements-based testing or RBT. It is the only architecture that ensures the right system is built, providing the maximum level of ISO 26262 compliance by anchoring every test to an engineering specification. But what exactly is a requirement? It is not a bureaucratic checklist. It is a highly specific, legally binding, and mechanically testable directive. It dictates exactly how a system must react under precise environmental conditions. Good requirements leave zero room for interpretation. They are essentially pre-formatted test scripts disguised as English sentences. They allow engineers to disconstruct or deconstruct intent into four critical pillars: the precondition, the trigger, the system action, and the performance metric. However, engineers face the impossibility of infinite test scenarios. Testing every possible velocity data point exhaustively is statistically redundant and wastes computational and engineering resources. To solve this, we use equivalence partitioning to divide inputs into zones where the system behavior is identical, reducing infinite possibilities down to highly potent and representative test cases. We then refine this further with a boundary value gauge. Software errors cluster at the strict boundaries due to logic flaws. By forcing tests at these exact failure fracture lines, right? Like testing at precisely 29, 30, 31 kilometers per hour, we can pinpoint potential failures with, you know, kind of surgical precision. Once these values are defined, we move from raw text to an executable protocol. The requirements is permanently locked to its execution instructions, defining the setup, the injection of data, and the expected results ready for the real world execution. The final piece of the architecture is the traceability web, the nervous system of automotive validation. Bidirectional links ensure that if a requirement changes, engineers instantly know exactly which software files and test scripts must be rewritten after that. Through a traceability dashboard, we track the golden thread that links a source requirement to a specific code commit, a validation test, and finally a passing results. This is essential for a successful ISO 26262 audit, safety audit. Requirements-based testing is not just a phase that happens at the end of a project, right? It is the horizontal bridge of the V model, locking what we imagined to what we actually built. It ensures total safety, total compliance, and flawless digital twin. The loop is closed here. Thank you.